From the very first spade in the ground to the very last lick of paint, over the next 2 hours you're going to learn every small detail so that this summer you'll be able to build yourself a bespoke garden room workshop. We're going to overcome some really tough challenges. Don't know what they're moaning about. Bloody easy. In some of the worst weather conditions I've ever built anything in. Another cold morning. But with plenty of resilience and hard work, we're going to overcome every single obstacle that's thrown at us. So sit tight, grab a brew, and by the end of this, I promise you, you'll be able to build yourself a bespoke garden room workshop. We're going to start excavating some land ready to build a workshop / garden room. I'm going to take this old shed down. It's pretty rotten anyway. To be honest, I was just going to knock it down. I was actually going to drive the digger through it. But my mate has now told me that he wants this to use as some sort of potting shed on his farm. So I've got to try and take it down without completely destroying it. But it's been there some years, so we'll see how that goes. He might have some repair work to do. So I'll start with the easy bits. Start by getting the doors out of the way first. I know very little about roses and flowers in general, so if I'm cutting back a rose bush wrong, tell me in the comments if you're a keen gardener. I don't think you'll want the old rotten trellis, so I'll have that out of the way. Right, let's see if any of the screws for the roof actually come out or if they're all too rusty. Surprised, they actually aren't too bad. If they all come out like that, this might not be too bad after all. I don't think there's going to be any struggles guessing what tool of the day is going to be. Don't say it. There's only the odd one that didn't play in ball, really. Nothing that we can't handle though. So the roof's too heavy. I'm never going to get it off on my own. I've got some bars in there, felt the weight of it. It's just not going to happen, and I've got nobody available today to come and give me a hand. This needs to get out of the way. What I'm going to try and do is unbolt each end panel, so this panel here and the back panel. I can see that they're bolted on with a simple nut and bolt, and then push the whole thing over flat pack. This could go horribly wrong, so I'm going to push this thing over and see if it survives. That's quicker. So all the bolts are out, and essentially all we've got now is a flat pack shed that's kind of propping itself up. You can see this thing is pretty much about to fall over, but there's something holding it together right on the ridge here. This is one of them where you keep the camera rolling just in case you fall off. Things I do for YouTube. There's got to be some nails under this tongue and groove holding this ridge onto the end panels, so we need to get them out. Persuader required. Right, now we're getting somewhere. Ooh, I think we might end up losing half the shed here. Right, I'm going around the back and I'm going to push it and let's see what happens. Yes, off. Let's do the other side. So you know I've been telling you for the last 3 years to give things a go at home. Well, probably best to strike this one up as entertainment only. Well, I did tell him it would be flat pack, so I'll have a little clear up. The shed's getting picked up tomorrow when the digger arrives. I need to start chopping down some of these old shrubs. Let's start attacking some of this and get it flattened off, ready for the digger. So we're back with our old friend, the reciprocating saw, for most of the bigger shrubs and trees. And then I just clear the rest of the area using shears and a strimmer just to flatten it off. And the digger will take care of the smaller stuff. Apart from that apple tree, we've got a lovely clear area for our workshop. What I do just want to do, just before the digger arrives, is just mark out, roughly, with some stakes, the area that we need to excavate. Because what I don't want to do is be wasting time doing that in a little while, because I've only got the digger for a day. So I'm going to go around with some little stakes, a lump hammer, and a tape measure. These are really good tapes, by the way. I really like it. It's my new go-to tape So I'm going to go round, I'm going to mark out the area, bang some stakes in, get it roughly square. Right, 600 off the boundary. So the reason I want to keep it 600mm from the boundary is mainly to give me access down the side of the building. And to keep the building within permitted development and not have to get planning permission, I'll need to fix non-combustible sheets to the sides that border onto the boundary. So leaving 600mm gives me space to fix the metal cladding, non-combustible sheets, and work on the fence if I need to. So I'm having this kind of debate with myself really. Do I go 4 by 5 meters or do I go 4 by 6 meters? I know timber's expensive at the moment, but I don't want to regret it later. So I'm thinking maybe I go 4 by 6. Well, bigger's always better. So let's go 4 by 6. Slight change to the original plan. So the total size of the workshop will be 24 square meters, which keeps it under the 30 square meters that we need to stay under for permitted development, which will also mean we can only go to 2.5 meters high at the highest point. So I've staked out a rough area. What I'm going to do now is just go around and square that up a bit, and then it'll be time to get the big boys toys out. So the digger has arrived, and this is the moment where we find out if it fits through the gate or whether I'm going to look really stupid. Or maybe I'll just take the gate out. Oh, it fits, whee! Nearly took the wall out. Whoop. Slight scratch. Right, first job of the day, we got to get this apple tree out because I want to try and save it. Whether it'll actually survive, who knows? But let's dig it out with a big ball around it, plonk it in a new hole, and then that thing will be out of the way. So I don't have a huge amount of experience on a mini digger, having only driven a couple before, and I've never driven one like this. So I did struggle a little bit to start with. Well, I intended to get a ball out, but the soil was a bit loose, so yeah, and I'm not used to driving this thing, so it's kind of fell over, but we'll see if it survives. Right, so that's the trees out the way. We can get on with digging out for the pad. So I've swapped over to the bigger bucket now, and I'm digging down around 200mm from the ground level and using the stakes just to give me a rough area. I'm just going around and getting the bulk of the soil off first, and then we'll go around and level it off and make it a bit prettier afterwards. Everything was going so smoothly until we ran into this problem. That's that point where that back wheel hits. So we've got this little mini dumper, and to be honest with you, this is a 2-wheel drive one, and the guy said that the 4-wheel drive one's broken. So we're really having a job getting the dumper up the ramp into the skip. It just keeps stalling. So we'll hit it again and see what happens. I just hope I don't have to handball all this into the skip. We managed to get it up there. I think we need to put a little bit less in it though, because it's an absolute nightmare. The longer I spent driving the digger, I did get a bit better at it, and by the end of the day I was good enough to get the ground nicely flattened out, and you can see here we've got a nice area to work with. Oh, that is job done. Hot work. That's the bulk of the soil out. So we've excavated the ground down to 200mm beneath our finished surface, which is highlighted by these stakes here. That'll give us the perfect level for our base. And I think I've earned a cold lemonade. So Hopefully you can hear me. We're filming here today during Storm Babbitt. What we're going to do first is shut her off. Now what that means is we're going to form a frame, and I'll show you how to do all of that so that we can build our concrete pad and contain all of that type 1 blind and sand and concrete within the frame. Obviously if we didn't build a frame it would all just spread out and we'd get absolutely nowhere. So we're going to be using these scaffolding deals, which are 220mm, and conveniently that's the perfect size for our concrete pad. Basically what we're going to do is build a frame with them. We'll be putting stakes in the ground, leveling these off, and that'll give us the perfect edge to run our tamper along when the concrete pour arrives. So because it's absolutely chucking it down, I think I'll probably just show you the process as we go along. So first we just start to lay a few boards out just to give us a starting point. We want to square off the back fence because that fence is square to the house. We'll then be able to square the sides off the back board so we know that the pad will be square to the house. We're now just levelling up the first of our boards to give us a bit of a datum point to work from. So this deal is staked in for now just so that it doesn't go anywhere. We know it's perfectly level and that gives us a datum point or a point to work off. So as long as we level the adjoining boards as they go, we should get everything perfectly level. And we also need to make sure that we get the corners square. There's a couple of ways you can do that. You can just use a big square like this, or you can use a 3-4-5 rule. Now to do 3-4-5, what you do, we'll measure 3 foot along our first board, make a mark there at 3 foot. You then measure 4 foot on your adjoining board, and the distance between the two marks should be 5 foot, so you'll know it's square. But double check that with your square just to be sure. We can now start to work in that direction, leveling the boards and squaring them up as we go. It's getting harder and we have got half of the shuttering done. It's horrible working in this, to be honest. I don't recommend it, so don't do that at home. Because the pad's going to be 6 meters long, we need our deals to run 6 meters long, so we'll just put some joiners in to extend them, and yeah, carry on moving in that direction. So we're getting there now, we're just putting the end bit in, obviously squaring it all up as we go. What we're going to do is just grab our tape and take a corner to corner measurement each side. If the measurement's the same, we'll know that the concrete pad is going to be perfectly square. So we'll take a corner to corner measurement this side first. 7220, 7220, bang on. We know that's perfectly square now. So our stakes will go just on the outside. We'll space them evenly along the length, making sure they're not proud of the top edge, because when we tamper it, if they're proud of the top edge, of course, we won't get a nice flat finish on the concrete. Then I'll just bang a couple of screws in just to hold them in place. And that's it, the shuttering is done. That gives us a nice sturdy frame. Yeah, as you can see, it's not let up all day, so I'm going to go and dry out and I'll catch up with you guys in the morning when we start to construct the pad. Day 2, and at last the rain has stopped. So as you can see, the type 1 MOT and the soft sand has arrived, and what we're going to do today is construct the sub base ready for our concrete to be poured. It's still going to be a fairly tough old day to move this type 1 because it's so dense and it's really hard to get a shovel into. Luckily I've got a few helpers and we should still get it all around there by the time the dumper has to go back. So the plan for the sub base is to have 100mm of Type 1 MOT to give us a nice solid base underneath the concrete. On top of the 100mm of Type 1, we're then going to put 20mm of blinding sand, which is just building sand or soft sand that sits on top of the Type 1, and that stops the DPM from getting any punctures or anything like that, especially when you're walking on it. If you didn't put any blinding sand down and you just put your DPM on top of your Type 1, because there's lots of sharp stones and things like that in the Type 1, you could end up puncturing it. So you need to make sure you put the blinding sand down before you lay the DPM. The purpose of the DPM is to stop moisture coming up from the ground into your concrete pad and of course then up into your workshop. So all of those elements are very important and they play their own individual part within the sub base. So I think what we'll do now is get some ramps up so that we can get the dumper over the shuttering, and then we'll start to bring some of the 5 tons of Type 1 round. If you need to calculate how much Type 1 you need or blinding sand, there are calculators online that can help you. It's going to be a tough old day. The graft begins. Hit the music. Spoke too soon. This is the thing with these jobs, you can't choose the weather unfortunately when you've hired dumpers and deliveries and things like that. It's just one of them things. We've got to crack on. And just to make things even better, we've got a flat tyre now. So it looks like we're going to be doing it the hard way. Wheelbarrow for now. When it rains, it pours. So we've got some of the Type 1 in, we've got a rough level, so we'll get the compactor on there, see where the level's at, and then we can fill any of the low spots. So I've got this little Hyundai compactor. It's a really great little compactor actually. I've used it a couple of times. It's perfect for this job. I'll just give this an initial run over with a compactor to start with. What I'm doing now is just going around and filling any of the low spots, and then I'll just continue working in that direction, compacting it and filling the low spots as I go. Bit of a relief, we have got enough. Took some of the highs off, filled some of the lows, and it's perfect. We've now got 120mm up to the finished level. That's 20mm of the blinding sand and 100mm of concrete. So I'll just run the compactor over this one last time, make sure it's all nice and compact. The Type 1 binds together nicely and gives us the perfect sub base to lay our blinding sand on top. So let's haul the sand round and get it on top of this. So we've got 20mm of compacted blinding sand. That now leaves us the DPM to go on top with the rebar and spacers to go in there as well before the concrete gets poured. So we've had to bodge up this tarpaulin over the whole thing. Now it's not ideal, but it's set to rain all day tomorrow morning, and that is when the concrete is turning up, and we're going to be pouring the concrete in here. Normally I'd recommend that if you guys are doing this job and it's set to rain like this, try and postpone it if you can. I can't, because I've got loads of jobs coming up in the next couple of weeks around other people's houses, media walls to build, all kinds of things, and I've got no other spare time to do my own stuff. So this has got to happen today, tomorrow. It's annoying, but we're just going to have to cover it up, keep the rain off it. If you get rain in your concrete, you could affect the mix, and you don't want that to happen. Once it goes hard, it doesn't matter. So the next bit of the concrete pad, we're going to lay the DPM, and we're going to put the mesh in on top with spacers. Now you have to put mesh or rebar in concrete, because that is what gives it the strength. Without the mesh, really the concrete is subject to cracking in the future. How much of this I actually get on film, I don't really know. It's going to be difficult with the weather, especially tomorrow, so I'll do my best for you guys. So my glorious assistants here are doing all the work while I talk to the camera, which they're really happy about. When you're doing your DPM, get it tight into the edges of the shuttering, because obviously you don't want any air bubbles or gaps to form along the edge of the DPM. So the DPM's all there. We're now getting the mesh in, laying it in with a 50mm gap from the edge, because if we go too close to the edges, you could risk puncturing the DPM. DPM is overlapping the shuttering all the way around, so we can fold up the walls. So we'll get this laid, or they'll get it laid, and then I will go around and put some spacers in. So you can see we're just tying all the spacers on now with the wire. That just sits the rebar up 50mm. Where the rebar sheets overlap, we tie those together as well to make them one. You need to have a spacer at least 2 per square metre, tie them all on, and that'll give us the strength once the concrete is poured. And here comes the rain. We couldn't buy a bit of luck on this build so far, unfortunately. So in about 10 minutes, we've got 2.8 cubic metres of C30 concrete being delivered. The rush is going to be on. I've got a few friends helping. All my little worker bees are going to be back and forth with wheelbarrows. And we've got 45 minutes because it's mixed on site, so that gives us a little bit of extra time. Normally you'd probably have about 30 minutes to get this done, but we've got a bit extra, which we might need in this weather. So we've got lots of people helping with barrows, and I'm going to set the camera going, a few different angles, and you can sit back and watch whilst we fill this thing up with concrete. Right, so concrete's in. We went a little bit over the 45 minutes. We've got it somewhere where we want it now. Obviously you can't mess around too much because you don't get a lot of time. What we're doing now is just tamping the concrete down, and then what you'll see is the guys are going to saw it, and they'll drag off any high spots, and that sawing action just gives us that nice smooth finish, and it takes off any of the high spots. And then what we do is we just come in with a shovel and fill any of the low spots as well, and we will end up with a nice smooth concrete pad. Don't know what they're moaning about. Bloody easy. It's the next day, and typically the sun's out. I'll be honest, that was a grim few days. It was hard to film in, it was hard to work in, and I'll be totally honest, if I weren't stuck with deadlines, I would have postponed it. If you can postpone, then postpone, because it does risk a good finish. We do have a couple of little drip marks in the finished pad. I've got a couple of choices there. I can fix them if I want to, but to be honest, once the floor goes down, I don't think it's going to be a big issue. The main thing is we've got a 6 metre by 4 metre solid foundation to build the workshop on. So for all the walls, we're using 4x2 pressure treated timber. Now the first wall we're going to build is the back wall. The first thing we're going to do is just tidy up all the ends of the timber. That just gives for better accuracy when we're building the walls. So we'll put them all on the saw, trim off the ends, and then start constructing the wall. So we need to ascertain the height of the wall, and to do that we need to make a few calculations, because we need to keep the building within permitted development, and because the edge of the building is within 1 metre to the boundary, we need to make sure that the finished height of the building from the existing ground level is no more than 2.5 metres high, and that will have an impact on the uprights that we're about to cut to create our wall. So we need to do a few calculations to work out the height of those uprights. The first number we need is the height of the pad as it sits currently, and the best way to do that is just fly a level off the pad, grab a tape and take a reading from the highest point of the ground. We've got 110 mil. If we take our total height of 2,500, that's 2.5 metres, and then we take off 110 for the pad, we'll then deduct 45 mil for our bottom plate, that's the bit of timber that sits on the concrete pad, and 45 mil for our top plate, that's the bit of timber that will run horizontally on the top of the wall. So far we're at 2.3 metres. We now need to deduct the thickness of the roof joists. They are 6x2s, so that's 150 mil, and then on top of the roof joists we're going to have 18 mil tongue and groove OSB, so we're going to take another 18 mil off that. But just to make it a little bit more complicated, the overhang on the front is going to be 500 mil long, and over every metre we're going to have a drop of 20 mil on the roof. So that overhang being 500 mil up on the front wall will mean that we need to drop it another 10 mil. So we'll take 10 mil off for the overhang. So it's 2122, but to be on the safe side, I'll take the extra 2 mil off and make it 2120. But I know what you're thinking, we're building the back wall, so why am I calculating the front wall, which is going to be higher? Well, that's because of drop. So over 4 metres, we're going to take off 20 mil per metre. So that drops the height of the back wall in relation to the front wall 80 mil. So to calculate the lengths of the upright for the back wall, we need to take another 80 mil off 2120, and that leaves us 2040. So we now know the length of the uprights for the back wall needs to be 2040. So we'll head over to the miter saw and cut all the uprights for the back wall to 2040. So we're building the walls on the pad, and then we're going to stand them up. That makes this the bottom plate and this the top plate. Now what we're going to do is cut our first upright to 2040, place that in between the two, and then we'll use the nail gun with 90 mil nails to fix that in place. If you don't have a nail gun, you can just use an impact driver with some good screws. I'll just square the end of the timber up like that, then using the nail gun, bang in a couple of nails. That is absolutely rock solid. It might be a frosty day, but the coat's had to come off. I'm getting hot. Whew. Right, so as you can see, we now have our first upright in over here, and what I'll do now is show you what measurements we use to continue those uprights all the way along the wall. We'll place the tape on the end of the wall, and then we'll make a mark at 400, and then we'll just measure every 400 and make a little mark. So we know we need an upright every 400 mil, but there's one more upright we need, and that is for the adjoining wall. It'll make a little bit more sense later, but this is what you need to do. Your adjoining wall will screw to this wall, and what that'll leave you with is nothing here for the plasterboard to tag onto on the inside. So what you want to do is make a little line and a little cross, and that tells us that we need an upright there for the plasterboard to tag into. So we want an upright at 100 mil, and then all the uprights every 400 mil all the way along the wall. So the eagle-eyed of you out there will notice that our wall's not long enough. Now that's because we've got 4.8 metre timbers, but we need to build a 6 metre wall. Now we need to join the wall together. There's a couple of ways we can do it. You could complete this wall, complete the panel, and then make a smaller panel and screw the two together. But that's a little bit more timber intensive. So the way I'm going to do this is place my 1.2 piece of timber onto the 4.8, and that makes 6 metres. I'll then use a small offcut to bridge the joint, and then I'll cut my upright slightly shorter to fit in between because it falls right on the joint. Now that just saves me a little bit of timber, and then what I'll do is make sure that my OSB sheet that goes on here bridges that joint so that you can't get any flex in it. The OSB will give it a little bit of extra strength. So we've constructed the back wall. What we're going to do now is put the OSB sheets on the outside of the wall before we stand it up in position. The reason for that is we use the OSB sheets to actually square the whole thing up. Now we've checked with a corner to corner measurement with the tape and it's only 3mm out, so it's pretty square already. But what we want to do is use the OSB sheets to square it up because we know the OSB is dead square out of the factory. So that's why we attach the OSB now at this stage before we stand the wall up, rather than attaching it afterwards, because we're going to use that as our aid to square the walls up. So if you look here, you can see why we made our uprights 400 centres, because the sheet now falls on half of that upright. So we don't need to cut the width of the sheets because they're perfect. All we need to do is cut the height of them, which saves us a little bit of work. So the total height of the wall with the top plate and bottom plate is 2130. So what we need to do is take a couple of mil off the top of the OSB and the bottom of the OSB so that the weight of the building doesn't sit on the OSB. We want the weight of the roof to sit on the top plate and the weight of the total building to sit on the bottom plate. If we make the OSB flush, we could compromise the structure. So we want to take a couple of mil off each. If you hear someone mucking around in the background, that's Chris. He seemed to be appearing in a lot of my videos lately. He's sort of in the background doing all the jobs that I don't want to do. So anyway, he's now going to cut the length. You can cut the OSB when it's on there if you want to. If you've got a track saw, it's a bit easier because you can set the depth. You can see here the board is flush with the end of the wall. Where if the wall belly's in at the middle, we're not too worried about that. We'll sort that in a minute. What we'll do is now whack a nail in this corner and then we'll be able to square the board by kicking the wall up or down. You can see us out very slightly because we've got a couple of mil here which we want, and then up here you can see it's running out. So what we'll do is we'll pull the wall this way, which will square the whole thing up. So we'll whack a nail in this corner here to give us a starting point. I've got 50mm ring shank nails in the nail gun now. Again, you can use screws, but it pulls the OSB in very slightly. Whack a nail in the corner, and then what we'll do is kick this wall plate down. And you can see that when I do that, it squares it up. That now brings that flush, so we know that that's dead square now, and we'll do that as we go along. So if we now whack a nail in that corner, we can then take a look at this top corner. Now just check we're still square on that top corner, put a nail in there, and we know that that is now dead square, and we'll do that on each board as we run along the wall. Now I'll draw a little mark just along this piece of timber so that I know where to put my nails. You can see the original nails, or screws if you use screws, on the top and bottom plate, so you know where to draw your line, and put nails throughout the sheet. So of course at this point the wall's not going to stand up on its own, so what we're going to do is just pick it up and lay it against the fence for now. Now if you get to this point and you don't have a fence to stand the wall up against, just use a couple of your uprights or something and just create a bit of an anchor to the floor somewhere, and that'll allow you to just hold that wall up and out of the way. So we'll get that out of the way, and then we'll move on to making the side wall, and that one is a little bit more technical because we've got a drop on it. So each upright is going to have a slight angle on it with a little bit taken off, and there's a calculation we can do which I'll show you next. So on to building the side walls, and this gets a little bit more technical than the back wall because we've got that slope or pitch on the roof. What I think is best to do is if I show you by drawing it out, then you'll understand the way I'm going to create the pitch on the roof. So if you imagine this is our side wall, what we want is a slight pitch on the roof. Now that's exaggerated, but you get the general idea, so the water will run off the top just like that. Now you could put an infill piece in here, so you could make a square wall and then infill this piece here. But I don't like that way of doing it. I want these uprights to be continuous. So over the length of our 4-metre wall, we're going to have 10 uprights. Now, if you imagine all of those uprights like that, I know there's not 10, but that doesn't really matter. From the front to the back, our uprights at the front need to be longer than the ones at the back there. And the cuts need to be slightly angled as well. Now this is really easy to work out, because if you think we've got 10 uprights, so that's an 80mm drop divided by our 10 uprights, which leaves us 8mm per upright. So I know I need to make each upright as we go along 8mm less than the last one. Now each upright needs a slight angle on the top. How do we work out what that angle is going to be? Now you could use a slide bevel for this to give you your angle. Luckily I've built one of these rooms before this size, and I know that last time I went with a 1 degree angle and that was the perfect cut. So I'm going to cheat a bit and I'm going to go with 1 degree because I know that works. 2072, take away 8, 2064 with a 1 degree cut. The pile's going down, which must mean we're building something. So our first side wall is made. Now remember that it's going to be stood up in that direction. What you don't want to do is create your drop the wrong side, because then of course it's a real pain in the backside. So we now know that this is our high point here, this is the top corner, so when we stand up it's in the right position. Of course, just like before, what we're going to do now is just put our OSB on, because we want to square the bottom and sides to make sure the wall is square. And then of course this top piece here runs off at a 1 degree angle, so we just need to run the saw to follow that top plate. That's going to be the easiest way to just take the extra length off the OSB. So what we'll do now is get the OSB, I'll nail it all down and just chop that bit off the top. So of course we just repeated what we did here on that wall over there, but with the highest point on this side, so we can just stand that one up. So what we got now is 3 walls. We've got the long back wall and the 2 sides, and we've got our back wall propped up against the fence. So what we can do now is just stand one of these side walls up, get it plumb and screw the corner together. We're going to use 100mm screws. I'll show you how we do it. We're just going to plumb it up, square it up. Now our concrete pad here is square, so we should be able to work to that. So when we stand this wall up, we'll get it roughly square, and then we'll get a big square in there to double check it. But for now we can just stand it along the edge of the pad and we should be somewhere where we want to be. So I've got some damp proof course here. I'm just going to roll that along under where our wall's going to sit. It's a bit belts and braces really, because we've got the damp proof membrane underneath the pad, so you shouldn't get any moisture rising up, but it gives you that little extra peace of mind that no moisture can get into the walls. So we're going to stand this wall up first, get that upright. We've got this little rough brace here, just so once we've got it upright we can actually just prop it, and that'll hold it there whilst we lift this wall up, because that's a bit of a 2-man lift, they're quite heavy, and then we can get in the corner there and hold it whilst we screw it. So because we've still got our shuttering in place, we can use that to give us another brace up onto this wall, so we can actually level this wall up. You grab that, Chris. So we can level that wall up so we know it's plumb, and it won't get in the way of this wall here when we put this one in. So we'll just put a little packer in here, 11mm, to allow for the USB, and that wall can stand up against this. So that kind of holds everything there whilst we get it all plumb and in place. So we've done the same over that end, so we've got 3 braces in now, 1 at each end and 1 in the middle. That gives us total control of the wall. The wall can't move now and we know it's plumb. What I'll do now is lift this up. Getting your fingers under it is the hardest bit. Got it? There we go. So the corner's pretty much plumb now. Just going to get a couple of screws in through this upright here onto that upright on the other wall, and that'll hold it there for us, and we can then just go along with some more 100mm screws and screw it in place. What you should now have is that wall perfectly level and that wall there perfectly level. So we know it's plumb, so if I grab this big square, what we can now do is just make any fine adjustments just to make sure that's perfectly square. So Chris has now just kicked that over a little bit, which has closed that gap up a couple of mil, and once we're done the same the other side, we'll fix the bottom plates down to the ground so they can't move. To fix my bottom plates down to the concrete pad, I start by drilling a pilot hole through the timber. I then follow this with a 6mm masonry SDS bit. I then use these 100mm DeWalt concrete anchors. They're perfect for holding down timber to this concrete, and we use an impact driver to fix those in place. Okay, so we have 3 walls bolted down to the concrete pad. Them concrete anchors we used, there'll be plenty to hold this down. You've got plenty of weight on it as well, so it's not going to go anywhere. What we're going to do now is move on to the two front walls. So our front wall's built in 3 stages really. You've got a cheek either side of whichever door you're having. So we'll have a cheek on the left hand side, a cheek on the right hand side, and then there'll be some infill panels in there that tie the lintel in, and that'll support all the weight above the door. That lintel will need to tie in to the 2 cheeks beside the door. It'll all make a little bit more sense when we start building. So we'll do another very little artistic drawing so that I can show you how the front wall is going to be constructed. So we've got our doorway first of all, which is going to be 1700 millimeters. So that's the doorway. And then we'll have a lintel running across the top of the doorway. I know it's a little bit wobbly, I promise our lintel won't be. And that lintel will sit on 2 cheeks. And the cheeks will be formed of a couple of little infill panels, these 2 here. And they need to be 300 mil. And then the rest of the wall will be made up of a couple of panels that we're now going to build, which will form the rest of that 6 metre length of wall, because obviously we've got a 6,000 mil wall here. So hopefully that makes a little bit of sense. We'll start by building the 2 1850s, then we'll put them little 300 panels in, and then we'll put the lintel in. So let's get cracking and I'll show you as we go along how we do it. Now if you remember right back to the start of the video, this front wall here is slightly taller than the back wall. So these front uprights between the bottom plate and top plate need to be 2120. So we're building our front walls exactly the same way as we did the walls that I showed you previously, and then you can see just like before I'm going round and nailing OSB onto those walls, and then we're going to lift the walls up into position. Right, that's somewhere roughly where we want it. Again, like before, we'll get it level, we'll get it plumb, get it square and bolt it to the ground. Another cold morning on the workshop build. We haven't had much favourable weather in this, have we? I did all that work in the summer and then came outside in the winter to build a workshop. Call me mad. So what we've done is we've built these little panels here. They're 300 mil, and what they do is allow our lintel to tie into them. So the lintel's an 8x2, so that's 200 mil. So we've made these panels 200 mil shorter than the top of the wall. For our lintel, that's for our lintel to sit on top. It's an 8x2 lintel. So we'll bolt the 2 together with some coach bolts. So we'll have a 4-inch lintel in effect. And that'll sit on top of these 2 panels. So what we'll do now is fix these 2 panels in place, make sure they're all nice and plumb and square, and then we'll get the lintel made up and put on top. So we make sure everything's nice and flush, and then we'll fix this in place. So we know that that is going nowhere. So you can see we've got a nice big 8x2 for our lintel. The length of that lintel needs to be 2266. So we're going to cut 2 lengths of 2266 and then bolt them together. So we're using 6 M8 bolts with a nut and a washer on the end to bolt the lintel together. We will space them evenly along the lintel and also stagger them from the top to the bottom of the piece of timber as well, just so that we don't warp or split the timber in the middle. And then we just trim the end of the bolt off with a grinder. So we've got the lintel up and we're going to now place it on top of these supports. You can see we've got this string line here, so we know when it's perfectly flush with both of the cheeks. So we'll just lift that in place, sit it on the support pieces, and now we can tie it in using some 100 mil screws in the bottom and in the sides. We're just holding it in place so it's perfectly flush, and then we'll just tie it in, and using the screws instead of nails just pulls it nice and tight. So we'll tie it in, a couple of screws at the bottom, a couple of screws in the sides. Do that both sides and you can see the lintel's perfectly flush with the top of the wall plate. Because the lintel doubled up is 90 mil and the timbers here are 100 mil, what you get is a slight gap discrepancy. But what we're going to do is, just before we put this bit of OSB on the front here, we'll just get a few packers and we'll just put some packers behind it to bring the OSB flush. It's easier to do that than to do it on the plasterboard on the inside. Packing out plasterboard is not quite as easy as packing out OSB, so I'd rather do it this way. And then that's pretty much it for the walls. We've got 4 walls now. We're going to get the roof on. First thing we're going to do is pull all the joists round. They're 4.8 metre lengths, so we've got a 4 metre span plus an overhang. So 6x2 will be plenty. If you're copying along to this project, you could use 5x2s bolted together, and that would give you a little bit more head height. So choosing a 6x2 saves me a little bit of work because I haven't got to bolt them together, but it does lose me a little bit of head height. But that's a trade-off that I chose. We've got our roof joists here. What we're going to do first is cut them to length. Now we've got an 80mm overhang on the back edge and a 455 overhang on the front edge. By the time we've got a perimeter on, that will bring us up to a 500mm overhang. So first we'll cut all the joists on the saw so we know the lengths are correct, and then we'll get them up onto the tops of the wall plates and space them out every 400. I'll show you all of that once we've got them cut. So we've got some joists cut to length. Now we're going to start to fix them onto the top plates on the front and the back of the building. Now they're going to be 400 centres, just like our uprights were. The first one will sit just against this side wall plate, and then we'll spike that down from the top using some 100mm screws. Then 400 centres, so the second one will be here, and we'll be able to screw up through the top plate here into the bottom of that joist. So we're going to get the first one up off the side wall there, and the first one up on that side wall. Then we'll run a string line across the front so that we know exactly where all of the joists need to go, so we get them all perfectly in line along the front. Otherwise, when we put the fascia on there, it's going to be all skew with, and that we don't want. So me a bit. Yeah, spot on. So we've got an 80mm overhang on the back, which should give us 455 on the front. I'm letting Chris do a little bit of the work. He said he wanted to do some of the work. I like to do it all normally, but you know, he said he wanted to do some. He's put a string line up. You can see that the string line runs from the first joist to the end joist, and then we can lift each joist onto the back wall plate and front wall plate. And what we're going to be able to do is then slide the joist forward until it's 1 millimetre from the string line. And that's the best way to make sure that all of the joists sit in line with one another and that they're in the correct position. So to fix the joists in place, all we do is go up from the bottom with some 100mm screws. And the screws, compared to nails, just pull it a little bit tighter on the roof, because on the walls we use nails. But the screws just pull it that little bit tighter. So that, if we look, is all the joists up now. And what we're going to do now is just fix the end ones. If you come this way, we'll put a bit of timber from this top plate here onto this joist. Because they're quite long lengths, they do tend to bow a little bit. So we'll fix this in position, we'll fix the other end in position, and then we'll put a row of noggins down the middle, and that stops them bowing or twisting. We've got some rain coming in and we're running out of light, so we're fighting against time now to get this stapled to the walls to protect it so the building can't succumb to any moisture. And we're going to put a big tarpaulin over the joists because we haven't got time to get the roof boarded today. We've got it from the floor to the roof joists in less than 3 days, about 2.5 days. Because I'm talking to the camera and moving the camera around, things do take longer when you're filming, often double the time actually. And we need to get this watertight before the rain comes in. So we're going to whack this breathable membrane on. We're going to just carry that around the building, cut it around the door and staple it to the OSB, and that will protect the OSB. I explained to you before that we leave the shuttering on to keep the DPM nice and tidy. And what we can do now, before we put the membrane on, is lift that DPM up and staple that up around the edges of the building, and that stops any moisture tracking under the walls and getting up into the timber. I'll fold it over on the corners and I'll just staple the whole lot, but I've got a little strip of OSB I just need to put in here before we put the membrane on. Now the breathable membrane's really easy to use. All you need to do is unroll it off the roll, wrap it around the building, and then you can just staple it in place with a staple gun, and you just overlap each pass as you go so that no moisture can get behind it. Guys, you can't really see me, but we've ran out of light. Chris is actually shining an impact driver light on my face. We have got a tarpaulin on the roof, we've got the rhino vent on, but we've completely lost the light. I'll pick up the camera again on the next dry, light day. Right, we've got daylight again. We completely ran out of daylight the other day and had to chuck a tarpaulin over the roof to keep the rain out. But we're back at it, and what we're doing at the minute is just putting some laddering down the side just to hold the perimeter for the cabin boards and the trims for the EPDM roof. I'll jump up on the roof in a minute and show you exactly what I mean once we've got these in place, but all we're doing is putting some essentially noggins along the edge of this joist here and screwing through to hold them on the top of the wall plate.
Baby, I have a taste, all the highs and the lows. No, you'll never be the same. I don't really wanna hurt you, but I can't control the pain. If you're sticking by my side, maybe we could be okay, okay.
And it was all going pretty well until that just happened. Don't you just love a 100 screw pickup?
I really hope that you will choose to stay through all the pain.
I know you told your friend you're not okay.
Right, you join me up on the roof. We now have a solid box. Joists are in, noggins are in, and we've done the ladder and perimeter around the side. I'll grab the camera off the tripod, take you around and show you how we did the ladder and explain it all to you a little bit better so that you understand it fully. Excuse me if I'm not looking at the camera. I don't want to fall through because that'd do some good views on YouTube. You can see the joists that we put on the top plate of the front and the back wall. And then we've created this laddering around the edge. Now that'll give us our overhang. You can see how we've formed this overhang here. Now we've put our laddering in, so we've screwed to the end joist here, put these pieces of timber in here, and then screwed the perimeter all the way around the building. That gives us a nice big overhang on the front and an overhang and a small overhang all the way around. But the overhang not only gives us the ability to put downlights in, gives it a nice effect, but also protects the building from our great British weather. So that's where we're up to. Now what we need to do is get the OSB up here. If you're following along, what you want to do is get a few boards up here to lay your tools on and give yourself a bit of an area to work from and walk around as well, because otherwise you're going to end up falling through. So let's get some tools up and start laying this stuff. 18mm OSB tongue and groove, and what we're going to do, we're going to make this one by gluing it together, and we're going to nail it down with a nail gun. 50mm ring shanks. You don't have to use them, you can use screws just like we did with the walls, though I prefer to use the nails because it doesn't pull the timber in and blister it. It gives you a nicer finish. So the nail's probably your preferred choice, but if all you've got is an impact driver and screws, go with that. So what we're going to do, nail this front edge first with the tongue facing away from us. We'll work from this left hand corner. Roof's nice and square, so it's pretty easy. We'll nail this front edge. Now don't nail this edge yet, because that edge will give us a little bit of flexibility to slide the tongue into. So that makes it a little bit easier. So we'll get the first row nailed down on this front edge. We'll glue all the joints and then slide them in as we go. Chris, just pass me that glue and I'll show them what glue we use. So this is 5 minute. I don't know if you can see. Can they see that on the camera? Is it too far away? Bring us in closer. This is the logo's come off. 5 minute lumberjack glue. I think it's from Tool Station, 20 odd quid. Once we've got it in the joint, it'll go off really quickly. It'll go off nice and hard as well, and it'll expand and leave foam out of the joints. And then what you do, once that's gone hard, you just go along and you scrape that off. And just like we did with the walls, we'll start by nailing the board in the corners. Just stick a couple in it for now. Because we've left this edge unnailed, you see, we've still got a bit of manoeuvrability to slide this next board in. Now it doesn't matter that the tongue and groove doesn't fall on a joist. Because we're gluing it, that will make the roof one, and it'll be perfectly fine to have your joints not falling on a joist. Bit of glue on that joint. Glue's gone cold. Yeah. To reduce the waste, that bit that we cut off that end then starts our next row back up the other end again, and that means we're always using that offcut to stagger the joints. So the tongue slots into our first board. Hopefully you can see that. What we're going to do is just overhang the roof very slightly, because it's not perfectly square. It is actually a couple of mil out, which I'm quite happy with on a building of this size. And what we're going to do is put a straight edge along it and run the saw along the overhang at the end, and that allows us to get all the edges perfect on the roof deck here before we put the EPDM rubber roof down. Once you get going, it gets a bit easier because you've got something to walk on. So once you've got the first couple of rows up, you're good to go really. Just keep working in one direction.
You'll never be the same. I don't really wanna hurt you, but I can't control the pain. If you're sticking by my side, maybe we could be okay. Okay, maybe you could be the change I need today. I promise that I've never felt this way. I really hope that you will choose to stay through what...
That's pretty much it for the roof deck. What we're going to do now is just run along the edges with the saw. It's going to get dark in about an hour, so we'll probably cover this back up with the tarpaulin, and then in the morning we will put the EPDM roof on. I'll show you the whole process, so I'll pick up the camera then. Right, it's a new day. Actually, it's a nice day. The first bit of sunny weather on this whole project so far. So this morning what we've done is just gone around the edges and sanded down the corners. Now if you can see that there, we've just given them a little sand down, and that is just to take the sharp corner off so it doesn't puncture the rubber roof. It's really thick rubber, so it shouldn't puncture anyway, but belts and braces, I feel better if I take the sharp corners off. So I've done that. We then scraped all the glue from the joints because it foams up a little bit, so we got a scraper, took all that off, and then give it a blow with a blower, so all of the dirt from our boots and glue and everything like that is off the roof. And we've now got a ladder here, and we're going to get the EPDM sheet up onto the roof. We'll lay it up on here, unroll it and get it on roughly. You see, most people don't film this bit because it's actually probably the hardest bit of getting the rubber roof on the roof. Oh god, that's going to pull me off the roof.
Happy day.
That was easy.
Yeah, I'm sure it was for you.
We've unrolled the sheet of EPDM and now we're just going to stretch it out over the roof.
Why are you laying down on the job?
Because I can't get down.
Because I can't get down. Someone moved the ladder. Right, so we have got the EPDM laid out on the roof. It's nice and square, and we've got enough excess hanging over the sides to work with. What we're going to do now is let that settle for a few days out in the sun. That'll just get all the little creases out and things like that, and then we'll come back and we'll glue it down. But for now, what we're going to do is just screw some battens around the side just to hold it there so the wind doesn't blow it away. So none of this EPDM here on the fascia is going to show because you're going to have cabin board or fascia board over this, and then the rubber roof trims on there as well. So we could, if we wanted, just screw through there to hold the rubber in place while it settles. We've got 2x1 battens, and we're going to double batten the building. Now we double batten it because we're going to be having vertical cladding. So what we're going to have is vertical battens first, then horizontals on the top of them. And that will give us a nice gap behind the battens for airflow to run up into the soffit as well. We'll start cracking on and I'll explain a little bit more as we go. So because we're putting battens on every 400, we need to fire our nails through the battens into an upright behind. We can't just fire it into the OSB because it won't hold. So we know that if we mark every 400, we'll hit an actual stud. The other way to do it, if you pull the membrane down, you'll be able to see the nails that we use to hold the OSB onto the studs, and you can just make a little mark. So now we've got our marks on there, we're going to put our vertical battens on first. So starting from the top, line it up with a mark, stick a nail in it, we get our level and nail it all the way down. Now on the corner here, it's very important that we get it dead in line with the corner. We'll put a vertical one right down the edge, and then we're going to fly our horizontals past very slightly and then cut them off with a multi-tool. I know the building's plumb and upright, so I know that I could just use that corner there to get that batten perfect. And I can just work my way down. Right, so that's the verticals. We'll do that all the way around the building and then move on to the horizontals. So what we're doing now is just putting our horizontal battens on. What that does is gives us an air gap for any moisture. Hopefully you won't get any anyway, but any moisture that builds up behind that cladding, and it also gives us a good fixing for our vertical cladding. I'll get this one on and then I'll level it, so I'll pin it at the end, and then from that point there I can just manipulate it with my level, and I can just run along and nail it and trip over as well. Nails. Again, see, it's always when you're filming, every time. We'll do that all the way from the bottom up to the top so that we've got a good fixing for our cladding all the way up. Our battens are on. You can see we've got the whole thing double battened now. If I take you around the back, let me just show you what we've done around there. We have, if you can see there, we've done the same on the back, but what we've done is spaced these battens out a little bit more. The horizontal battens are the same. You can see the corners there, exactly the same as the front. The vertical battens are at 700, and that's because the back of the building there is just having the non-combustible metal sheets. They're just going to tech screw through into the battens, and there's no weight there at all. It's not like the cladding. It's very, very light stuff, so we don't need to worry too much about the 400 centres on the battens around the back. Before I do any more to the outside, I'm going to get the door in this thing. Getting the door on will stop all the water blowing in here. So that's what I want to do this afternoon, get that door in. So the door I'm using is from TWF Roller Garage Doors. Their link will be down below in the description. I like them because they're a DIY order. They're really easy to fit. I mean, I'm here on my own today. I'm going to fit this garage door on my own. It'll probably take me a couple of hours. They're super easy. Now, if you were doing this build as a garden room, you would have probably carried your bottom plate all the way across to create a door threshold, and you'd have then been able to put a set of bifolds or French doors or whatever you want to put in there, and it would have been a garden room really instead of a workshop. If you want to see more about how to fit a roller door, click on this link here because that shows you the process kind of step by step. I'm going to breeze over this today. I'll still show you a little bit how to do it, but it's not going to be so much of a guide. So first thing I'm going to do is cut my guide rails down. These guide rails, what they do is they sit just behind your door because this is a behind fit door, and then the curtain runs down in the guide rails. Above the guide rails sits, if I show you, it's upside down, but above the guide rails sits the top box. That's what the curtain's held within, and that top box sits on top of the guide rails on these little lugs here. So essentially what I've done is cut down the guide rails to length, allowed the space for the top box for it to sit on top of the guide rails. You can see that now sits just directly under the joists here. Like I say, if you want more precise info, check out the other video, but that's essentially what you got to do, sit the top box on the top of the guide rails. Now before we go any further, I'll just check the level of the top box. Absolutely bang on. So now we can fix the guide rails in place before we fix the top box. It's really easy because it's a timber frame building. All we're going to do is screw it all the way through the hole into the timber behind. So our top box is supported by the guide rails, but I just want to put a little fixing through the casing in the top of the top box here, just to bear some of the weight, so all the weight is not on the guide rails. This is quite a small door, so I don't think it makes a huge amount of difference. It's just a bit belts and braces really. So I'll lift the curtain up into position. It's actually harder to explain how to do this than it is to do it. I've put the lock and springs onto the rings. They slide on to hold the lock and springs in place. And then with a little key fob here, I've just pressed up, and that way the curtain's rolled itself onto the motor bar. And now we'll be able to get the door into the guide rails and set the limits. The door comes with this little tool here. It's a little hex tool, and that helps you to adjust the limits. So what you do is you just slide that little tool into the hex key there, and you can adjust the top and bottom limits by turning that key. And we'll stop with roughly one slat of the curtain showing underneath the top box. So the top limit's set. I can now lift the bottom slat into the guide rails. Just be careful not to scratch it as you do this. And there we go, that is perfect. That's the curtain installed. So we're now going to set the bottom limit. I'll close the door down first to see where it stops. Working in darkness, hopefully you can see me. Okay, so you can see that the door stops short. I'll hold the down button on the remote and turn the hex key until all the slats concertina down together and the door's fully closed. Top and bottom limits are set. Let's give the door a test. All the slats should concertina together fully, just like that. So the door's installed. I've just got to put the cover on the top box now and put a couple of little caps in the screw holes behind, and that is a workshop door fully installed. Cladding, the stuff that hides all of my hard work so far on the workshop build. And we're going to be installing this Ecoscape Forma composite cladding. It's the silver birch colour, which I think is going to look really nice with the black door and the rubber roof and everything else. I think the effect's going to look really good. And we're going to install the metal box profiles on the back of the building as well. So the lads have sort of made a start in the background. They're doing a bit of setting out for the cladding. I'll give you a bit of a walk around first so that you understand what we're doing. Do you know, whenever you're talking to camera, these lot start up a saw. And if we walk around to the back, what we're going to do on the back, we're going to clad this with metal box profile sheets. And there's a couple of reasons we use the metal box profile sheets on the back and the other side that's not visible. Reason one, it's cheaper by quite a long way. Probably the more important reason we use the metal box profile on the back is because it's a non-combustible material, and you need that non-combustible because we're within a metre from the boundary. So to stay within permitted development, we have to make it non-combustible on the edges where the boundary are. So once we've got that nice composite cladding on the front of the building, we're going to go round and do the metal sheets on the sides. Normally I would have done the roof first, so got the fascias on first, got the EPDM glued down, but we haven't been able to because we use this perma-roof glue to glue the roof, and you can't use that stuff if the temperature drops below freezing for 48 hours. So we've been held up on the roof. So we're going to do the cladding first, do the soffits, clad them as well in the composite cladding, and then we're going to do the roof last. Just a little bit more back to front than how I wanted to do it. So Luke is setting an external corner for our reveals so that we can clad the reveal up to the door. Now there's a couple of ways you could do this. You could use Ecoscape's reveal trims, and let me show you this side. I don't want to stop him working. So normally what you do is your reveal trim would come up to the door and your cladding would slot into it, and that would hide your reveal and look really neat. But just because of how it's worked out, unfortunately in this case, our reveal trim doesn't cover because we're having our cladding vertically and we're double battened. Unfortunately, that was a bit of an oversight. It's one of them things, in hindsight, I'd have probably had an inside fit door because I could have brought the guide rails of the door further forward to cover them with the reveal trims. But there you go, one of them little learnings when you've never used a product before, you'd never know. I've got a board in there already, look, you can see how nice it looks. The plan was, when we built the building, to use cedar. So Western red cedar, we were going to have that vertically installed with secret nails, so you just pin it to the battens. So there's already a few differences because we've changed the plan and they've gone with a composite cladding. We've never used this product before, so we're learning all the time as we go along, and you guys are going to learn with us. So to start with, rather than using a starter bar on the bottom, we've got an F-trim, but you don't have to use them. You can actually just cut a straight edge on the cladding board, but I think having a trim just gives it a nicer edge. We've installed the corner trim as well, so we need to make sure that the corner is plumb from the beginning, because if we get these trims out at all, when we put the cladding boards in and work our way along the wall, they'll all start to creep over.
The F-trims and corner trims are really easy to install. You've just got a pilot hole and countersink all the way through into the batten, and then use a wood screw to fix them in place.
So the first board's in. I'll show you how we fix them in a minute, but the first thing we need to do is cut the length of the board. So the best way to do this is take a measurement between the two trims and then make the board 12 millimeters longer than that measurement. So the board's been cut and it should now fit between the two trims. Now, if we place the bottom of the board in first and then the top, it should just fit, which it does.
You can then slide the board up into the top trim by 6 millimeters.
So now we've got the expansion gap we need, we can fix that board in place. So we've got the little Ecoscape clips, and what we do is we position them along the length of the board, but we only fix them on the middle two battens. So these battens here are 50 mil apart, and what that does is it fixes the board in place but allows the board to expand above the screws and below the screws, but it still gives it a fixing in the middle. Now the clips along the rest of the length of the board only have to be screwed to the batten and not to the board itself. So we've got a few boards on. It's looking quite good already. Luke's fixing them. Chris is Well, Chris said that we're working too slowly, didn't you?
I did, definitely too slow.
So what he's doing now, like, is he's trying to cut. How many you got there? 3. Or is that a guide? No, so he's cutting 2 at once because we're working too slow. So, so Luke's fixing, Chris is cutting. I don't really know what that leaves me doing. Talking, not a lot exactly. So once you get going, you get pretty quick at it, to be fair. Now I'm really happy with that. I think that looks absolutely mega. Once we've done the whole thing, it's going to look great. It's starting to come along really nicely now. We're a couple of hours in, and we've got a quarter of it done. So my reveal trims are on. They're perfectly plumb. We've got some nice 45s on the corners. I'm really happy with how that looks now. And then we will clad into those. I don't know if you can hear, but I'm actually losing my voice. Hopefully the microphone can still pick me up. But I'm out here getting this done because we're, as usual, on a bit of a time limit. So the bits I need above the door are 153, so I'll cut the first one at 153, and then there's a little trick to cutting loads of boards the same length at once. And put the blade against the material which you cut, and then grab a pencil and make a little mark on the saw, so that every time I can just line the material up to the pencil mark and I know I get the perfect cut. The weather's turned again. It's horrible out here now, the great British weather. So yeah, this front bit is done now. It looks really, really nice. We've just got the side to do. If you're wondering what's going to happen at the bottom there, the slabs are going to come up to where the DPM finishes, so we'll have a nice finish with a slight gap underneath the cladding. It's more of the same now. We keep putting them boards on, and then I'll show you the finished product when we get to the corner of the building and start to clad the back sides, the boundary sides, with our non-combustible metal cladding.
You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh.
And that is the composite cladding complete. And now what we're going to do is move on to the back corner, and I'm going to start to show you how we fix the metal box profile in place on our boundary edges. So this is what we're using on our boundary edges to give us that non-combustible that we need for the permitted development rules. It's metal box profile from a company called Cladco. Now there's not a lot of room to film down here, but I'm going to cut the next one and show you how we fix it in place. It's actually really, really easy, and it only takes about 5 minutes to put each sheet on, so it's a lot quicker than your cladding. We've put a few screws in for now. I'll probably come back and put a few more in once we've got them all up. If you look at the first one we've put up, we've started from the corner where our cladding is, and we've just slotted it into this corner trim here, and that actually gives us a really nice neat finish. So now what we're going to do is carry on in that direction. We've taken a measurement from the soffit down to the bottom batten, and that gives us the perfect finished height. We'll transfer that measurement onto the metal box profile, and then I'll use a grinder to cut it to length. Once you've cut the stuff to length, it's really easy, he says as he struggles, to lift it up to the soffit, and then what we're going to do is get a couple of screws in it. Now the screws that you get are these ones from Cladco. They've got a washer already attached to them, and all you do, hold it in place, and quite simply just put these little tech screws into the profile like that. So we've got a bunch of them in. What we're going to do now is go around the rest of the sheet, screw it in place. So you get these little caps as well, colour-coded caps, and we'll just pop them over the heads of the screws, and you'll never see them. And with your cladding, you'll want some of these. These are stitcher screws, and where the sheets overlap, you just pop one of these screws in. Again, they're tech screws, so all you do is drive them in, and that will stitch that together and make it a really tight joint, so no water can get in and the wind can't get behind it or anything like that. So we've done both of the boundary sides, and we've worked our way to the corner of the building now, and because the building has a fall on the roof, we've had to cut a slight angle on the top of the metal sheets, but that's really easy. Basically it's 20mm
per metre width of box profile, or you can just take measurements and do it that way. So what I've done is cut the box section of the profile off so that our corner flashing fits flush over this flat section here. It's quite hard to film down there because there isn't a lot of room, but basically just like before, we've cut our corner flashing to length. So I'll just lift that on, hold it in place, and then I'm going to screw it to the battens just like we did with the box profile sheets. So Chris has just taken a measurement of our perimeter, and then what we're going to do is, if you follow me over here, we've got our fascia boards. They are 200mm, and it's a tiny little sliver that we actually need to take off our 200mm width. So Chris has devised this little tool. He's been working on this for hours now, not really. How long have you been working on this? Half hour? Something like that. We're going to cut these with the circular saw. Now Chris has made this little jig, and that basically sits in the lip of the fascia board, and then the circular saw sits within the jig. You can just slide it along, and that'll allow us to cut off the exact measurement that we need. So we can just buzz that all the way along and they'll be perfect. So I've set the circular saw depth to the thickness of the board, and I've set the jig so that when I now run this down the board, I'll be able to rip off that little thin piece that we need to take off. And you can see that we just took off that little sliver so that the width of our fascia board is now perfect. Oh, and little giant ladders, the only ladders you really need because they're so versatile. Since I've had these, I haven't got any other ladders out of the back of the van. So if you're in the market for a ladder, get a little giant. So the first board we're going to bring flush with the perimeter, the timber here. It doesn't really matter because they've got corner trims that go over them anyway, but if we start flush and the bit that overshoots at the end, we can just trim that off. And to make it a little bit easier, grab a couple of clamps like this, and that'll just hold it there whilst you get some nails in. The nails we use for the fascia are these black Plastop nails. We're just going to hit them in, they'll go through nice and easy. I'm going to put them a hammer width apart. It's a bit hard for Chris to film this from there. Like that, they go in nice and easy. They need to be the perfect height because you've got a trim that's going to come down over this, so we want the pins to come underneath that trim. We're having a debate here about hand saws. Chris thinks they take more skill, don't you?
They do take more skill.
Well, I don't know. I'm
No batteries involved.
There is that. Power tools are cooler. But that's my argument anyway. So, we've got the first fascia up. Now if you look down here, the first fascia runs past the perimeter. And what we're going to do now is just buzz that off with the multi-tool, because power tools are cooler. Speaking of power tools, every single week on my website, Ultimate Tool Competitions, we kit people out with power tools. We've already given away tens of thousands of pounds of power tools. So head over to the link in the description if you want to win power tool kits like this. You could be the next one getting that call from me. I'll see you over there. So just like that, that's the old bit. There we go. That is nice and flush with the corner, and the corner trim will hide all that. And now we're just going to whiz round the rest of the building and put all the fascias on. So the fascias are all on. I'm going to go around and do the corner trims once we've got the rubber roof finished. So that's what we're going to do next. We're going to glue the rubber roof down onto the roof deck. But before we do that, we need to come to the back of the building and put a batten along the fascia at the top, and that is to bring our gutter trim out a little bit so that the water falls down nicely into the gutter. If we don't do that, we're going to find that the water's going to miss the gutter because the trim is not going to sit out far enough. So we're now going to glue the rubber EPDM roof down to the roof deck. Now the first stage of gluing the rubber down is to roll it back halfway along the roof. So we're going to grab the rubber and we'll roll that back halfway. Can be a bit tricky on your own. It's helpful if you've got someone to give you a hand with it, really. Now we did give this a little tidy up before we put the rubber on, but I'm just going to use a blower. You can use a broom, whatever. Just get any grit off your boots or anything like that off the roof before we glue it. So this is the adhesive. It's Perma Roof for the Firestone EPDM rubber roof that we're now going to glue down. It's really easy to use. I'll show you how to use it once I get back up on the roof, but the only real thing to watch out is that you don't use it in freezing temperatures. Now it's quite thick stuff. Don't skimp on it. It goes quite far. And then we're just going to roll that onto the roof deck.
but try not to get any standing kind of blobs of adhesive on there or anything like that. Now there are spray adhesives that you can use around the edges, but we don't need to do that because we're going to be fixing our rubber through the trims and into the fascias. So we don't need an extra adhesive around the edges, but I'll show you that once I've got this down. So that's the adhesive onto the deck, right up to halfway, and you'll find that that'll start to go tacky quite quickly. Once it starts to go tacky, we're going to roll the rubber back over the roof.
Now, this is the bit that's a lot easier if there's two of you. Unfortunately, I didn't have anyone around to give me a hand, so it was a little bit more of a struggle. But gradually roll the rubber out onto the glue, and then I like to use a big long brush to sweep out any air bubbles or pockets of air from underneath the rubber so that you get a nice smooth finish on the roof.
And now what we're going to do is move on to getting the EPDM trims onto the roof. So they overlap our fascias and our rubber, and they pin the whole thing nice and tight around the sides. We're going to start with the side trims, and then I'll show you the guttering trims along the back edge.
Before you fix the trims, just peel the protective film off.
With the EPDM roof, you get these poly tops, just like we did with the fascias. We'll hit them in with a hammer, only this time we've got these little pre-drilled holes. Now what they do is they allow the trim to expand and contract and move a little bit around the pin. So we want to make sure we hit the pin in the middle of those little holes, and that way that trim can move. Now it's a bit tricky because you've got to hold everything and do this all at the same time. So I found my corner and I'll pull all that rubber tight. What I'm doing is just pushing that pin in, and that way it's nipping the rubber to the fascia behind so that the rubber stays taut. And then what I'm going to do is just hammer that home. And now we continue this way, keep the rubber pulled tight, tension on the top of the trim, hold it all there, poly pin in, drive the poly pin home. And then you just pop the corner trim over the corner.
And then we'll use the pins just to fix the corners in place.
Your joints, what you want to do is just leave a small gap for expansion, and then these little joint trims, they just pop over the side like that, line them up, and that just neatens the whole thing up. So now we're at the back corner here, and we're going to install the gutter trim. These are a slimmer profile trim. The first piece of that gutter trim sits with the chamfered edge along the top of our batten for our guttering. So we've folded the rubber back over. Now we've got identical trims. Rather than having them this way up, we're going to have them this way up with this edge curling over the top, and that is going to nip our rubber nice and tight to the trim underneath. And the holes in the trims will line up, so you'll be able to nail the poly pins all the way through both trims and the rubber, which will pull everything nice and tight. And that is the rubber roof done. All that leaves us is the gutter at the back, which I'm going to do tomorrow because the sun is setting. But what I do just want to quickly do is trim off the rubber around the edge. What we've got now is our fascia underneath that rubber. So I'm going to get a knife and I'm going to cut along the bottom of the rubber roof trim, and I'm going to run the blade at an angle up into that rubber along the rubber roof trim, and that's going to cut that nice and tidy. If you don't run your blade at an angle, you're going to see it. So make sure you run that blade at an upwards angle, and be careful not to slip. Take your time because you don't want to scratch the fascia. Now I'm just finishing up the joint trims and corner trims for the fascia boards, and they come in a 300mm length. So I've cut one down and it will trim that fascia nicely. The corners work in exactly the same way. They just cover up the joints and our corners. All you're going to need is something like this miter bond, a 2-part adhesive, and you just want to stick one side of the trim. You don't want to stick both sides because then the board can't expand and contract and it could crack the trim. So all we do with this is just stick one side of it with the glue, and I'll spray the activator onto the trim and quite simply stick the trim on. Make sure it's nice and level. Do that on all the corners and all the joints, and that is your roof complete. So this video has been a monumental effort for us to film. It's been the hardest video for me to film in the whole 3 years that I've been doing this channel, and that was because of illness. In one of the clips you heard I didn't really have a voice. I lost my voice for a few days. I couldn't film. We had material delays, we've had weather delays, we couldn't do the roof because of the frost, and it's gone on over multiple filming sessions. And I hope it's been a good video and you're enjoying it so far. If you are, leave us a comment down below, let me know, and let me know what else you want to see, because that's really important for me to bring the best content that I can for you guys on YouTube. And make sure you subscribe because you don't want to miss future videos, and hit like because that helps us let the video reach more people on YouTube. And now we've done the outside minus the guttering and the paving, I think it's the perfect time to show you guys what we created. $50 meters of 10mm armour cable. This is what we need to power the workshop, so that we can power things like lights, sockets, heaters and garden lighting as well. And once we've got all the cables in, we're going to insulate the workshop, and we're going to use the world's most expensive tin foil and foam. Not only is this stuff really expensive, it's going to be a pain to get this from the house to the workshop. So stick around and watch the pain and suffering. So the reason it's going to take some effort is because we need to run the cable quite a long way. It's about 46 meters, something like that, from the consumer unit around the front of the house in the garage to the workshop. The consumer unit's going to be on the other side of this wall at the back corner of the workshop, and we then need to run our cable all the way down here behind this old shed and all the way down the side of the house. And then we're going to gland it off on this wall here so that it can go through to the consumer unit in the garage. So when you're taking your armour cable up to a shed, workshop, garden room, whatever it might be, you need to comply with the regulations. And if I'm honest, none of them are particularly fun. But choice number one, you can surface mount the cable. So I could mount it to this wall, to the fence posts, all the way to the workshop, and that's probably the quickest and easiest way, but it is unsightly. So I've gone for option number two, and option number two is to bury the cable, and that's the route that I'm going to go down because it just looks better. But what we do need to make sure is that we either bury the cable deep enough in places where it's vulnerable to something like a spade, or make sure it's protected by something like this concrete pathway here, or the paving slabs that it's going to be run under. So I've dug from the workshop all the way down the side of the garden under where the new paving slabs are going to go, so I'm not too worried about that. The old paving slabs will go back over this until we put the new ones down, and if you were to lift those paving slabs up you'd see the cable anyway, so I'm not too worried about the cable being fully protected until we get the new paving slabs down. Now I'm just cutting this little channel across here so that we can gland the armour cable off. So as long as the cable's either visible or protected, I'm not too worried about this being perfect for now. Right, so now our armour cable's in, what we're going to do, we're going to get on with first fixing all the electrics for the workshop. This is Sam, he's an electrician, he's going to be helping me on this today. All we're going to do is start drilling everything out first. All the holes in the joists to run the cables for the downlights. With the sun, I don't know if you can see this, but I've got some little bits of tape with crosses on them where I've marked out for the downlights for the soffits. We've got a laser set up so we know where these holes need to go for the cables, and we're using spade bits to drill 20mm holes through each joist in the middle so that we can run the cables. When we're drilling these holes, we're doing them in the centres of the joists. Structurally, that maintains the strength of the joist, and when we go and plasterboard this, we don't want any screws to hit the cable, so we want to be 50mm or more away from the surface of the ceiling. Hang on, are you in the camera?
I don't know.
Go on.
Right, we're now drilling holes up for your switches, your sockets. This is the consumer unit here, so we'll drill the holes up.
Yeah.
And then we'll fish the cables down.
So you're going through the top plates?
Yeah, going through the top.
Yeah. Okay, cool. Through the top, into the ceiling, and down where the consumer unit is.
Yeah, I am.
You are on it. This is his first time on camera, give him a break. And because I was messing around talking, I forgot to put the microphone on, but you can see we're pulling the cables through all the joists and then we're clipping them in place.
And once we've got the cables clipped to the joists, we're just going to coil them up so that they're out the way for the plasterboarding. So I'm just putting the feed into the switch. Our consumer unit's going here, and I've got to get a cable up through this top plate, through this hole, and then clip it all the way along this joist here to the switch. It's quite difficult because of how I finished the end joist on the top plate. Means that I've had to put a little draw wire in here. I did spend 5 minutes off camera fumbling around, I'll be honest, but I've got this wire in. And now you can see I'm taping my draw wire to my cable, and then that will allow me to just pull that draw wire and pull my cable through. I've got a 70mm hole saw now. I'm just drilling the holes for the downlights. We're putting quick wire downlights in, so we'll be able to pull our cables in, put the quick wire connectors on, and then I can plug the lights in a little bit later once we second fix. This composite cladding is actually really hard to drill through, and it's messy. Wow, that is really messy. But you can see what I'm doing, getting the holes in, and then we can get these cables in. Whilst I've been drilling the holes for the downlights in the soffits, Sam's been pulling the cables in for the double sockets around the room. Like I did with the lights, he's gone from the consumer unit with a 2.5mm twin and earth up through the top plate, through the first joist, down to the first socket, then back up, down to that corner over there, back up, down to this corner over here, and then down to the last double socket over here. So I've written here FCU for the heater, because I'm going to put a heater on this wall here. So there'll be a fuse connection unit here, and we're going to run a separate circuit, again just back to the consumer unit for that. And then that really will be all the cables. Now if you're wondering why we've put a ring in rather than a radial, it's really just for future expansion. I think that just future-proofs the building a little bit more. The only thing we really need to do now is put a bit of 10mm in, so that's what we're doing now, a bit of 10mm from where the consumer unit's going to go down to the bottom of the wall plate, ready to go through to the whisker box on the other side. So the last little job that I want to do before we move on to insulating the room is to fit my quick wire downlights, and I've also got some nice black bezels with these, and they're going to go really well with the black door, black fascias, and the colour theme that I've gone with. So even though I can't use them yet because there's not even a consumer unit in until we second fix, at least it's going to look smart for now. So if you've been watching the channel for a while, you'll know that quick wire downlights are pretty much the only downlight that I use now. And that's because of the quick wire connectors. It's so easy to use. All I've got to do is wire this up, and once I've wired all these up, I can just go along and clip the downlights in. They even put a mark on their wire strippers so that you can see exactly where you need to strip back. You don't even have to put any earth sleeving on the conductors. You just pop live, neutral and earth into the quick wire connector, and it is quite literally very quick. Then I can just plug my downlight in, push the cable up through the hole, and you can see you can install a downlight in a matter of seconds. I don't even think that would take me a minute to install that downlight. That's how quick they are. And there you go. How good does that look with the black bezels? So that's one of our 5 soffit downlights installed. You can see how quick they are. If you like the quick wire downlights or any of their other great products, hit the link in the description below and check out quick wire. The kids are already loading my workshop up with their toys. So what we're going to do now is move on to this massive pile of Actis Hybris insulation. And at a first glance, it really does look like the most expensive tin foil and foam in the world. This pile of insulation here cost me £900, but it's actually quite comparable to the cost of something like PIR, so Kingspan or Celotex for example, but there's loads of benefits to using this Actis Hybris. This is not sponsored, this is just my opinion. I've used this stuff in the past and it is incredible to use. It's ridiculously easy to install and it makes no mess, because PIR is just a messy job. If you've used it before, you'll know what I mean. So this cuts down on all that mess, and in my opinion, it's quicker to cut and use. So I'll install this Actis Hybris in the walls first, and then I'm going to do the roof. We're going to do a cold roof. I'll explain a bit more about a cold roof when we get to the roof, so keep around for that bit, because that bit's probably more interesting and more important than the walls. So this is the 90mm Actis Hybris. Our studs are 400 centres, but between the studs we've got 360mm, and what we need to do is cut down the Actis Hybris to fit
within the two studs, and we'll cut it about 5mm too big so that it pushes into the space nicely and doesn't fall out. So to cut this, take a length for the Actus Hybris. It comes all coiled up, so it's really easy to work with. Measure the distance between the two studs, which we know is 360, so I want to make that a tiny bit bigger, about 5mm bigger. Put a mark on the Actus, and then you want one of these. This is like a bread knife for a jigsaw. I get these from Amazon. They are made by Bosch, and that's long enough to pass right through that bit of Actus Hybris. Let me show you. Make sure the Actus is all bunched up because it's easier to cut that way, and then you'll just be able to pass that blade through the length. Now you grab these two little tabs at the end and you pull the Actus into its final form. And all we do now is pop that in between the two studs. But you want to leave about a 10-15mm gap from the finished surface where the plasterboard's going to go. That's for airflow. That's what Actus recommend that you do. And then you just want to pull it all the way to the top. Make sure you're covering any gaps. And that is really all there is to installing this stuff. And in just a couple of hours, I had all the walls insulated. But now we need to insulate the roof. So for garden rooms, I prefer to go with a cold roof. Now what that means is there's a space between the top of the insulation and the roof deck above, and that allows vapour to travel over the top of the insulation, and that way you won't get any damp issues. I'm going to do one of my very artistic little drawings to show you what my ventilation system is. So this will be the insulation in the ceiling with a gap above of 50mm, and when we double battened the walls for the cladding, we left 50mm for airflow behind the cladding. So at the bottom, air can come up into the cavity, it can travel up across the top of the insulation, and that way it can ventilate our cold roof. Now you want a 50mm airflow gap. It's roughly 50mm. You don't have to be precise with this. It's the same stuff we just used for the walls, but being 105mm, that's going to leave us a few mil under 50mm between the roof deck and the top of that insulation for airflow. There's a few other things we need to consider when we're doing the Actus Hybris in the roof. It's the cables. We need to just make sure we tuck the insulation around the cables. Do the best you can. Cables are always going to be in the way. What we don't want to do is end up pushing insulation above the cables, because then we haven't got a cold roof. So we always want to try and make sure we go around the cable where we can. So it'll probably take me another couple of hours to do this roof because it's quite a big space. So let's get on with it. Hit the music. My helper's arrived again now. I don't know where you've been, now all the work's done.
Holiday.
We've got 26 sheets of 12.5mm square edge plasterboard. We do the ceiling first because then we can bring the walls up into the ceiling. It's easier to cut it that way and it gives you a better finish. All we need for this is this collated screw gun. It's much easier than using an impact driver and a pocket full of screws, so that'll make the job a lot quicker. I appreciate that's quite a specialist tool. If you're doing this at home, of course you can use an impact driver and drywall screws. Make sure you get the coarse thread ones. That's all you need really. It's slower, but if that's what you got, go with that. Before you go plasterboarding anything, make sure that you write a plan of where your cables are, because of course we've first fixed all the cables and we need to know where the holes need to go once this is plastered so that we can cut the holes and pull them through. And do the same for things like sockets and switches as well. So we need to assemble our makeshift plasterboard lifter. I'll show you that in a moment, and then we'll get the first board up. So this is our homemade plasterboard lifter, another one of Chris's masterpieces. We were plasterboarding this whole flat, and
I think at the time we couldn't hire one or whatever, so we made this, and it was actually brilliant because it lifts up and down. You can pump it up and down, so you just put a bit of plasterboard on the top, pump it up, and the good thing is you can stand on it as well and screw it as you go. So yeah, that's done a lot of work, that has. It's nothing fancy by any means, but hey, it's good. First sheet's up, we've got a laser line running down this joist here. So we're going to work in this direction, so we'll square this edge up with this joist where the laser is, and then we're going to stagger the joints, but we'll get this one up first. So what we've got is our first board on our laser line there, so we know it's nice and square, and then any cuts we can make along the walls. We'll get a bunch of screws in, probably about 5 across the width of the board. We've marked our joists, and then we'll come back later and just put all our screws in, but for now we'll just get the boards up. So the ceiling's plasterboarded, we are moving on to the walls now. We're going to start with this back wall. This one's nice and easy because it's just the same height all the way along. The side walls, we've got a fall on them. If you watch the video where I built the building, you'll know that there's a 20mm fall per metre. But we'll do this wall first because it's a nice easy place to start. There's no other reason than that. You can see I'm there throwing tools at me. You can see that I've set my laser level up. Let me bring you in a little bit closer, and we'll fit our first board up to that laser level, and we'll work our way in either direction. So we'll start here. We've measured the height. We are going to sit it on a bit of plasterboard. That gives us a little gap at the bottom. There's absolutely no way you're going to get any moisture coming up, but if anything's spilt in the room, we don't want it to track up the walls, so we sit it on this little packer, and that just brings the plasterboard up a bit. So measure it, cut it, screw it. Now when you get your boards up, you won't be able to see where your uprights are to screw to. What you want to do is just make a little mark where each upright is, because then you're going to know where you need to put your screws. So that one's up. Now we just keep working in one direction. Hey Chris, how'd you get a footprint up there?
It's easy, easy.
You'll know that there's a fall on this roof. Now what that means is that when you're cutting your plasterboard, of course, this side of the piece of plasterboard is going to be taller than this side of the piece of plasterboard. So if you can remember the fall, I know it's 20mm per metre, then brilliant. If not, you'll need to take 2 measurements from the front of the board to the back of the board, and you'll be able to tell how much you need to cut off the top of the board. Now all the boards are up, I can just run around and put the rest of the screws in, and that shouldn't really take any time at all. Plasterboarding's done. As you know, this is a 6 metre by 4 metre room, so it's quite a lot of plasterboarding. 25 sheets in the end and 1,000 drywall screws. What we're going to do now is go around and put all our pattress boxes in for the light switches, heater and the sockets. So we're going to go around, do that. I'll show you how we mark them out and cut the holes so we can pull our cables through, because at the moment all our cables are of course behind the plasterboard. Now before I plasterboarded, I made note of where my sockets are going to go. So I know this socket needs to be 500mm from the corner, and the bottom of it wants to be 450 from the floor. Now I've got my box and a little level, and all I'm going to do is I'll just draw around the box. Now I've got my multi-tool and I'm just going to cut on those lines. Now there's a cable behind here, so what I do is just do this very carefully, just plunge through the plasterboard, and you'll feel, it's kind of a feel thing, you can feel when you come through the other side of the plasterboard, and at that point you just stop the blade, because of course you don't want to damage the outer insulation of the cable. You can see the cables for our ringer behind there. Now all we do is just lift that up, pull them through, and there you go, no damage on them at all. Little knockout there, just pop that out, and we can just fit our box. Very easy to fit. Pop the little lugs in, and there you go. That's a box installed. I've just coiled the cable up, left that in the back of the box, and that's ready to second fix onto. So I'm going to put the holes in for the downlights now, and I took measurements from each wall so that I know exactly where the cables are for the downlights and where the holes need to go. So all I've got to do now is measure from the walls, replicate those marks, and then I'll run a laser down the room so that I know exactly where to drill the holes. So I've got my line, and I know that my first downlight is 880 millimeters from that wall, and I've taken a measurement for each downlight as I work my way across the room. Now I'll just make a little mark on the ceiling so I know where to drill the hole. Now I've got a 70mm hole saw and a dade. What the dade does is stops all the dust from coming back in your face, because it's not very pleasant getting a face full of plasterboard.
Now be mindful, there's likely to be cables behind the plasterboard, so go easy.
And you can see that that catches all the dust.
And now you'll be able to pull your cables through.
So that's all the holes in for the downlights. And I've got 10 quick wire downlights, the same ones we used for the soffits on the outside, but this time with white bezels. And now I'm going to wire my quick wire connectors onto my cables. I'll cut them short, I'll put the connectors on, and I'll pop them up in the ceiling so that that makes it easier to plaster the ceiling, and then we can just pop them down afterwards and plug the light in. So before we plaster, we're getting all the scrim tape on. It's 4-inch scrim tape.
Now scrim tape doesn't have to be pretty, but it does have to be stuck well, and it has to be on every joint of plasterboard. You can see I use my trowel just to stick that in place. I do that throughout the whole room, and the only thing I do have to be careful of is that I don't overlap bits of scrim.
Now the reason we use the scrim across all the joints, anywhere where the plasterboard meets or up in corners, is to stop it cracking. If you don't use scrim, eventually you'll get cracks, and them cracks are going to travel all the way along the board. As you can see, this is a fair size ceiling. It's a 6x4 metre building, so this ceiling's probably nearly a 3-bagger, so not something I could take on. That's why I've got the professional here today, my plasterer. He's going to be giving me a hand with this one, and I'm going to kind of labour for him. I'll probably do a little bit, but I'm certainly not good enough to take this one on. So he's going to do this one with us. Don't get any on the floor, will you?
That's a bit hard not to.
So I am pretty much just going to labour for Andy. Keep feeding him hawks full of plaster so we can get it on nice and quick. Especially because we've got the door open, we don't want this to go off too quick and become unmanageable. So the plaster's on, and what we're going to do now is start troweling it up. Andy's never used a speed skim before because he's old school, he's a trowel man through and through. I have used the speed skim and I really like it. So the little challenge is that we're going to get Andy to do the first trowel up on this with a speed skim, and then he can tell us what he thinks about it as a professional plasterer, because I'm not. So, what do you think?
I'll have a go.
Yeah, give it a try. Right. Yeah, give it a go and let us know what you think. So he's been using this about 10 minutes now, and he now said to me, I weren't filming, but he now said to me, I actually really like this, didn't you?
Yeah, it's not so bad.
So the old boy might be converted. That's the ceiling all done. It makes the room look even bigger now. And then tomorrow we're going to be back out here doing some of the walls. Of course, I'm not going to make you sit through the same process again, so I'll do some sort of little edit. The longest bit of any spraying job, masking off. Luckily, there's not a lot to do in here. I've only really got to mask the edges of the door and the cables, and then we can get spraying. So mist coat is a thin layer of white paint, so it's white emulsion mixed with water, and we're going to spray that on using the Wagner 250R sprayer. Because this is quite a big space, using the sprayer is going to be so much quicker than if we were to use a roller and a brush. For this mist coat, I've gone with 2.5 litres of cold, clean water, and then we've got 10 litres of the white matte emulsion from Dulux, and we're going to put that in with this water in a 15 litre paint scuttle. Now I'm putting all that in there because this is quite a big room and we're going to use it up. The paint sprayer absolutely rinses through paint. This is going to dry really, really fast. That plaster is going to suck the moisture out of that paint. I'd imagine the first coat will dry easily within half an hour, and we'll probably end up just going over this a couple of times, and then we'll be able to get a top coat of white over the top. If you're following along, of course, once you've done the mist coats, you can paint this whatever colour you want. That to be what, 2 minutes if that? This thing is so quick. In a room like this, it's a no-brainer. So I'm going to do the walls now, and I reckon that'll take me another 4 minutes. I look like I've been in a snowstorm. It's white, and that is all I wanted. Clean, white, done. What we're going to do now is move on to the second fixing of the electric, so I can finally get this room powered up. Quick wire downlights are really the only downlight that I use these days. You can install a quick wire downlight in a matter of seconds, not even a minute, and that's because of the quick wire quick connector system. And I think what we'll do, we've got 10 of these to install, and we'll have a little bit of fun and see how quickly I can install 10 downlights. Now this is going to be nice and quick because I've already got the quick wire connectors on my cable. I'm going to speed the video up so you don't get bored, and then I'll show you how long this took at the end. Time is going, let's go. 4 minutes and 35 seconds to install 10 downlights. How quick is that? And that is why they're called quick wire. Quick wire downlights are the best, and that's why they sponsor this channel. I'll put a link down below in the description. Go check them out because they make my life and your life so much easier. Thanks, quick wire. I then moved on to installing my door controls, but silly me didn't mark where the studs were, so I ended up having to fix this with plasterboard fixings, and then I got it all wired up. The door's working, all good. Of course, once we've got the workshop powered up, we will plug the door into this double socket. So this is where the wiring gets a little bit more complicated because we've got a 2-gang switch going on here. So we've got one switch to operate the lights inside and another switch to operate the soffit lights outside. Now it's a little bit more complicated, but I'll show you how I make it easy. So we've got 3 cables coming down from the switch. You can see I wrote on these when we were first fixing. We've got the feed coming into the switch, so that's got a permanent live in there. We've got the inside lights, down lights inside, and the soffit lights, so the lights outside. So I start by stripping back all of my cables, and then I add earth sleeving to all of the bare copper earth conductors. I then put all of the earths into a Wago and tuck them in the back of the box. I'm going to strip back my neutral conductors and do the same with those. I pop them in a Wago and tuck them in the back of the box so they're out the way. The only thing that leaves us with is 3 brown conductors. So we've got the feed, inside lights and outside lights. And we now need to wire those into the switch. So we've got a 2-gang switch, and what we want is a permanent live feed, so that feed in cable. We want that to go into the common, so you can see there's a common terminal there, so permanent live into the common. And then we're going to link the 2 commons together with a small link wire. What that does is gives each switch a permanent live feed. So it'll give a permanent live to the inside lights and a permanent live to the outside lights. So we've got the permanent live feed coming into the first common terminal. Then we're going to put the link wire into the other common terminal. Do that one up as well. That leaves us 2 brown conductors. We've got the switch line for the inside lights and the switch line for the outside lights. So I'll strip those 2 back. So we've got L1 on this side of the switch and L1 on this side of the switch, and then we just pop those into the L1 terminals on each side of the switch. And now we can just pop that switch back to the wall. I then move on to wiring up my sockets, which are on a ring. If you want individual instructions on how to wire up sockets, I've got a playlist on the main channel, and I'll link that down below in the description. All the second fixing's done apart from this, the little consumer unit. Before we boarded the wall, I made notes of where the cables were so I could just cut a hole and pull them through. I can then fix the consumer unit in place on plasterboard fixings. Sam does this every day, so I'm going to leave him to do the wiring on the consumer unit.
First thing I'll do is I'll strip all the cables back. I don't know why I'm bothering to speak because Cam's going to edit me out anyway. So now, as you can see, I've got the main switch in and I've put the MCBs in, and now it's ready to be terminated. So first I like to connect my mains cable in, which is the bigger 10mm cable, and that comes from the consumer unit in the garage. I always like to connect that in first and dress it in as neat as I can. These smaller boards aren't always easy because there's not as much space as in a normal size fuse board. Right, so that's the neutrals and the earths both connected in. And finally, you've just got to connect the lives, which get dressed into these MCBs here. And that is your lives connected into the MCBs. And finally, we just got to put the buzz bar in, which goes in the bottom there. That's the buzz bar connected in there. So this fuse board is all done. Okay, sorry Cam, I'm terrible at this.
So that was Sam's first time presenting, so go easy on him. Hopefully you understood a little bit about a consumer unit install from that little clip there. So we've got a storm gland on the whisker box, glanded that off there, and I'll just mark where the holes are and fix this box to the wall. I then connect up the cables within the whisker box to connect the 10mm from the consumer unit in the garage to our armoured cable feeding the workshop. So someone's going to notice we haven't put the earth leads on the SWA at this end. We have earthed them on the other ends of the cables. We couldn't do it this end because of the reducer that goes in the whisker box. And by connecting this little lead, we've earthed the SWA. I'll just pop a little bit of silicone sealant where the cable's going through the back of the box there. Just pop the cover on. And job's a good one. The consumer unit's in and the power's on. So what we're going to do, we'll do some testing in a minute, but let's just see. We have light. These are the Duraflex floor tile range in black and in grey so that we can make a checkered pattern. You'll see how awesome that looks in a minute when we start to lay them. And they come from a place called Garage Floors Direct, and they are a solid 7mm thick vinyl PVC floor tile. Now Garage Floors Direct did supply these tiles for my workshop, but I went and seeked them out because I've used a product like this before and I know how good these are, and I wanted to show you guys how great they are in a workshop. What we've got there is a row of tiles that I've laid out so that we can gauge what the cuts are going to be either side. We'll lay a row lengthways along the workshop as well, and if you look behind me there's a little gap here and a little gap over here, and we'll be able to slide the tiles left or right, and we'll be able to work out how much cut of a tile we want either side of the room. So you can see that took less than 2 minutes to lay one whole row of tiles in each direction, and now we can have a little play and see what the gaps are like either side. Because this is a checked pattern, what we don't want is small cuts or uneven cuts each side of the room. We want to measure those cuts to make sure they're nice and even. So if we look, we've got a little cut here, that's probably about half a tile, and we've got a little bit more over here, so that looks a little bit uneven. There's a smaller gap that end than there is down this end. Grab a tape measure, and we're just going to even up the gap. So to the interlocking face from the wall on this side, we've got 430. We're going to leave a 5mm gap around the edge, but that doesn't matter at the moment. We just want to make sure we get these tiles centered. So we've got 430. We're going to do the same that end. So the gap that end of the room is roughly 100mm bigger than that end of the room. So if we shuffle the whole thing that way by 50mm, and check again, we should be somewhere where we want to be. So check again, 390mm, and we've got 390 up this end as well. So that little shuffle weren't a bad guess at all actually. Shuffling them up 50mm has given us the perfect even gap on each side of the room. The setting out is always the bit with any tiling, PVC or ceramic or whatever tiles you're doing. That's the bit that takes the most time. And the next thing we need to work out are where the ramps are going to go. So I've got a long straight edge, and to work out where my door closes against the floor, I'm just going to draw a little line along the back of the edge from the guide rails on each side of the roller door. So by making a mark like that across the front, I know where the door is going to drop down. I want the door to drop down just before this ramp here. So I know that this face just needs to sit back from that line very slightly. So I think it wants to sit somewhere there. So I fit the ramp to the tiles and then I shuffle the whole thing along until it meets the line. So I'm just going to start laying some tiles, get the bulk of this down. For clicking the interlock and sections together, you'll want a soft face hammer. So let's get the bulk of this floor laid. I reckon that's only going to take me half an hour max to do a 6x4 metre room, which is crazy. And then at the end, we'll go around and we'll do all the little intricate cuts. And I'll show you how we cut this stuff. So you can see how quick and easy this stuff is to lay. It literally just clicks together. It's taken me about half hour to lay the whole of this floor, and now all we've got is the cuts and intricate bits left around the edge. So I'm going to show you how to cut this stuff, how to do all the little intricate bits around the edges. So we've got nice even gaps all the way around the room for our cuts. The only intricate bit in this room is around the door, so we'll do that last. What we want to do now is fill in around the edges. So we'll cut all of these tiles and click them in around the edge. So you can see our tile doesn't quite fit. We need to remove a section of this tile. So I've laid the tile in the space and I need a 5mm gap around any edges. The 5mm around the edge is to allow for expansion. That's the recommendation for these tiles. For me, it's not too bad because I've got an 18mm skirting board, so I could leave a slightly bigger gap if I wanted to, or even slightly smaller because I've got a gap underneath the plasterboard running around the walls. So I don't need to worry too much, but just make sure you've got a gap around the edge for expansion. To find out how much I need to remove, I just flip the tile over and then using my marker, I'm just marking the gap onto the bottom of the tile so I know how much to cut off. So the first method of cutting these tiles, the one that doesn't need any power tools, all you're going to need is a sharp Stanley knife and a straight edge. Now we've got a mark on the tile, I'll lay my straight edge across it. I'll run the sharp Stanley knife along the straight edge, probably about 3 times. So we've got a score mark along that tile there. I'm just going to flip the tile over, then I'll put some pressure on there and you'll see the tile will start to split. You can use my feet as well. There you go, you can see it's starting to split now. Now I'll grab my knife again and I'm just going to run the knife along the cut. So we can just slice the tile. And you can see, using a sharp knife like that does make a nice cut, but it is a lot harder work. The other way of doing it, we could just take a measurement of the cut that we want. We'll then transfer that measurement onto the tile and use a straight edge to give ourselves a line to cut along. There's 2 power tools you could use to cut this stuff. The first one is a jigsaw with a fine tooth blade on it. A nice laminate blade would go through that really easily. Or you could use a circular saw or a track saw, anything really that you can get a straight cut with. This has got a Nesdal blade in it. These are super sharp blades and it'll go through this stuff really easily. Whichever cutting method you choose, you can then just use your hammer to lock the tiles together just like we did before. I found a little way that you can do loads of cuts really quickly. So if I just take my measurement of the cut that I want, because the walls are nice and square in my case, I really can just repeat this size cut all the way along the back wall of the workshop. So all I've done is marked out the 190 that I want for the cut and lay the tile on a nice long bit of grass, set the circular saw depth to the 7mm of the tile thickness. And by doing this, the blade can pass through by 1mm or 2 into the grass and it won't cause any damage. And it also supports the saw and the tile so that we get nice straight cuts. And that's the quickest way to get lots of nice straight cuts, and then you can just go along with the hammer and interlock all those pieces. So the bits around the door are probably the trickiest bit of the job, and because this is quite a nice square room, there's not many tricky bits in here. I've got this little section that I've cut what we're going to find is even though it fits on this tile, it doesn't fit with the door ramp here. So I remove that section of ramp and then I'm going to cut it down to the edge of the door and reinstall it. So now we've just got this little section to infill here. The skirting board will cover most of it, but we want to continue that grey and black checkered pattern into this section here. I made that cut nice and tight so the piece fits perfectly, and once the skirting board goes on, you won't even notice. Speaking of skirting board, that's what we need to do next. We'll get that skirting board on. I've got a bunch of square edge skirting board. I'm going to measure the lengths, cut them on the saw, then I've got an 18 gauge nail gun or pin gun, and I'm going to pop round and just nail them all to the wall.
Me feeling like a firebolt high in the sky, looking like a thunderstorm. Here we go, You're easy to remember, so hard to forget. That baby is a cowardly strut. How could I not worship every inch your feet have touched? Baby, run away with me. You kill it lonely. You make my eyes unsee.
And now it's had a good old mop, check out how good that looks. In fact, I'm wearing socks because it's almost too nice to use as a workshop. I've just got the skirting boards to caulk and paint, but I'll do them a little bit later. So guys, there it is, and I hope over the last 2 hours you've learned everything there is to know and you'll be able to build one of these yourself. If you've enjoyed it, head and check these videos out and I'll see you guys in the next one.